So here the transpose of cofactors of the given determinant. Cofactors of all elements in the matrix is called adjoint of matrix. And it is denoted by adjoint of A. So I'll represent adjoint of A as A is A. So let us see how to find it. If we consider an example, first we'll see for 2 by 2 matrix, then we'll go for 3 by 3 matrix also. Let us consider this matrix A. That A is matrix 1, 2, 3, 4. 2 by 2 matrix. Then its transpose. How to find its transpose? Adjoint of matrix. First we need to find the cofactor of each element. So let us write transpose of. So while writing the cofactors, as we know that I power minus 1 power I plus j. So the first one is plus sign, the next one is minus sign, and the next one is minus sign, and the next one is plus sign. If you find the minor and cofactor also, you get the same result. So let us consider the first one 1. So delete this row and column. So the remaining value is 4, isn't it?
Yes, sir.
So this is
Yes, sir.
similarly for 2, cofactor is minus 3, and for 3, cofactor is minus 2.
Minus 2.
Cofactor is 1, isn't it, ma'am?
Yes, sir.
Now it is a transpose of cofactors of the elements of the given matrix. So adjoint of A is, write its transpose. So we'll get it as 4 minus 3 minus 2 1. This is the adjoint of given matrix A. Is it clear?
Yes, sir.
Yes, sir.
Sir.
If it is 2 by 2 matrix, no, directly we can write, see, interchange the principal diagonal elements. If you interchange, what you'll get it? It is 4 and 1. And change the sign of other diagonal elements. So it is minus 2 and minus 3. We get the same result or not? These two are.
Yes, sir.
So what do you observe? In 2 by 2 matrix, we can find the adjoint of a given matrix. The principal diagonal elements can be interchanged, as well as the anti-principal diagonal elements sign could be changed. Then the obtained matrix is called adjoint of matrix A. Is it clear, ma?
Yes, sir.
Right. Let us consider it as that matrix A is 1, 1, 2, 2, 3, 5, 2, 0, 1. So first fix the signs. It is easy to get it. If you want, you can do it one by one, minor and cofactor also. It is your wish. Right?
Yes,
So
sir.
write these transpose. First find the cofactors of these. So adjoint A equal to, you can fix the sign first. First one is plus, next one is minus, the next one is plus. So alternate signs will get it.
Minus, plus, minus,
Then plus,
plus, minus,
minus,
plus.
plus. These are fixed signs. Then if you get the minor value is minus, suppose in this minus 2. So again you have to write in the bracket minus 2. Don't forget it. So here we know that the formula for a cofactor is minus 1 whole to the power of I plus j, right? M ij. So minus 1 whole to the power of first element 1 plus 1 m11. This is minus 1 even power mass. So plus m11 will get it. The next element m12. So m12 minus means minus 1 whole to the power of 1 plus 2. So it is minus 1 m12. So minus m12. So first one is we fixed as plus sign. The next one we fixed as minus sign. Instead of doing this. Is it clear, Ma?
Yes, sir.
Yes, sir.
But actually procedure is this one only. Ma. We have to do it one by one. Now, to get the cofactor of 1, delete this row and column. If you delete this row and column, what will get this result?
3.
3.
3 minus 0, isn't it?
Yes, sir.
This is 3 ones are 3 minus 5 0 0. So 3 minus 0 is 3. So directly you can write 3. If you do it, I feel it's good. At last you can write this. Or else we'll write it. A11 is minus 1 whole to the power of 1 plus 1. Determinant of 3501. So this is minus 1 whole square into this is 3 minus 0. So 1 into 3 equal to 3. So this is the way you have to find for all the elements. While you're writing the notes or examination, you have to do this. When they ask only for adjoint of A. If they ask to find the inverse, directly also you can proceed to save your time. Okay, ma?
Yes, sir.
Yes.
Right. Then go to the next one. So the next element is 1. So delete this row and delete this column. What will get it, ma? Now?
Minus 8.
So the remaining elements are 2, 5, 2, 1, isn't it? Determinant. So this is 2 minus 5 2s are 10. So minus 8. See, the determinant value is minus 8, a minor value. So already minus is fixed. So you should write minus of minus 8. And the next one. Let us take the next one. What will get it next one? This is 2. Delete this row and column.
Minus 6.
Minus 6.
Yes, 0 minus 6 is minus 6. So plus half minus 6. And the next one. Go to 2. So delete this row and column. So that is 1 minus 0.
1.
So what about rest of Alma, where you are understanding it or not? No response. If you could not understand, then see this one. Delete this row through 2 and delete this column. If you delete this row and this column, the remaining elements are 1,
1 minus 0.
0 and 1. Yes. So we can write 1, 2, 0, 1. You can, for your convenience, you can write this one also. So this is 1 minus 0, the result is 1. So this is plus 1. So you can write directly 1. Minus already fixed, you should not change it. Next, go to 3. Delete this row and column. So the remaining elements are 1,
1,
2,
2, 2, 1.
1. So the result is 1 minus 4
1 minus 4 minus 3.
minus 3 plus half minus 3. And the next one. What is the next one?
-2.
5. So delete this row and column. So the remaining elements are
1, 1, 2, 0.
1, 1, 2, 0. So that it is 0 minus
0 minus 2.
is minus 2.
Minus 2.
So this is minus 2. Right? The next one is 2. So delete this row and column. So the remaining elements are
1,
-1.
5.
1, 2, 3, 5. So 5 ones are 5 minus
5 minus 6
is minus 1.
minus 1.
So plus half minus 1. Next, go to 0. Delete this row and column. So 1, 2, 2, 5.
5 minus 4.
So this is 5
minus
minus 4 is 1. So plus 1 plus, if you want, you can write. Next, at last, go to the 1. So delete
3
this
minus 2, 1.
1, 1, 2, 3.
2, 3. 3
So
minus
3
2.
minus 2 equal to 1. So this is 1. So you should write either transpose or you should write T. T means transpose. Right?
Yes, sir.
Next,
Sir,
write the transpose. What you'll get the transpose. Therefore, adjoint of A is transpose of this matrix. Sir, we wrote already transpose, so can we leave that? We should not leave there itself. We should complete till the final step. So write till the transpose. While writing the transpose, row write as column. First row as first column. So 3 minus of minus
8 minus
and minus
minus 6.
and the next one minus 1 plus of
Minus 1,
minus 3 minus of minus plus
2.
plus of minus minus 1. This is minus 1.
Minus 1 plus 1.
That's it. So within 3 steps, by doing this small rough work, you can get the adjoint of A. Right?
Yes, sir.
What about rest of all? Only 2 members are responding.
Sir, if it is 4 mark, these 3 steps are enough, sir.
Wow. Just for your convenience, when it is, I said initially, when it is inverse, you do that. In inverse also, in the next question, next step, A inverse is 1 by det A into adjoint A. So in this case, you can do the same. If it is only adjoint is asked, you show these also in the right side. Anyhow, you have to do that only. Without doing, you could not get it.
Do that in rough work itself, no, sir. No need main column, no, sir.
Sorry, ma'am?
Can do that in rough work itself, no, sir.
No, not only rough work, ma, you can complete in the right side part also. Draw the line and you can complete. I did not complete in order. You complete in order. Right?
Yes, sir.
So just I want to show you this. We can easily get the result. When we go to the next question, one question I'll do it. How to do it, I'll show you. So in this question, they asked to find A inverse. A inverse is exists when that A is not equal to 0. So this is the first condition. So first we have to verify that A. If A is not equal to 0, this is called non-singular matrix. Suppose that A equal to 0. That is called singular matrix. So we have to verify two cases whether it has infinite solutions or no solutions. So that we'll discuss it later. So first let us find A inverse if that A is not equal to 0. So let us find that A value. So what will get that A? That A is expanding along R1. A C1. C1 is easy. So 1 into, delete this row and column. Isn't it?
10 minus 0.
10 minus 0.
10 minus 0. And minus
10.
0 plus 0. Expanding along C1. So the result is, that implies that A equal to 10, which is not equal to 0. Therefore, that A is not equal to 0. It is non-singular matrix. So, A inverse exists. Right?
Yes,
A
sir.
inverse exists. How to find A inverse? So, A inverse equal to, we have the theorem statements. No? First, let us complete this. At last, we'll discuss the theorem statements. If we discuss now, you will get the confusion for it. So the formula is 1 by det A into adjoint A. Det A already we got it. The result we know that, right? What is det A value?
Yes, sir.
So 10.
10. So now we have to find adjoint A. So how to find adjoint A? Here I'll show you that stepwise how to do that. Then you can follow the same. Given in notes and examination for other questions also. First, let us find cofactors of each element in A. So cofactor of 1. What you'll get? Cofactor of 1 is
10.
minus 1 whole to the power of 1 plus 1 into, this is 10 minus 0. So the result is minus of plus 2 is
10.
1 into 10.
10.
Yes. So it is 10. Right? And the next one. So for our convenience, I'll write it here. So this is 10. Next, cofactor of 2. So this is for making you understand. If it is inverse, you can proceed direct also. It's your wish. Minus 1 whole to the power of, what is the next one? First row, second column.
0 minus 0.
1 plus 2 and 0 minus 0. So anyhow, the result is 0 only. So
0.
0. And the next one, 3.
Cofactor of 3.
Yes, cofactor of 3.
0.
Factor of 3. You write this one also. Minus 1 whole to the power of 1 plus 3.
1 plus 3.
1 plus 3.
0 minus 0.
0 minus 0 is 0. So we need not simplify directly. You can write 0. So this result is 0. And the next one, cofactor of
0.
0. So minus 1 whole to the power of second
10
row.
minus 1.
2 plus 1. You should not forget to write this one. 2 plus 1 into, delete this row and column. 10 minus 0. What will get the result?
Minus 10.
This is
Minus 10.
minus 1 cube into 10, so that it is minus 10. So let us write minus 10. Next.
Cofactor of 2.
So cofactor of 2. Minus 1 whole to the power of 2
2
plus
plus 2.
2 plus 2.
into the remaining values. Delete the row and column.
0 minus 0.
So the result is, this is minus 1 whole to the power
5.
of into 5. So it is 5. So let us write this is 1. And the next one, cofactor of
4.
4. Cofactor of 4 is, oh, we need this one. Minus 1 whole to the power of
2 plus 3.
2 plus 3 into the remaining value. So
0 minus 6.
read this row
0 minus 0.
and 0 minus 0. So this result is directly we can write 0. So this is 0. Similarly, we have to find for the remaining 3 also. What are those? Cofactor of
0, 0, 5.
0, 0, 5.
I'm going to write here cofactor of 0 is what will get the answer? Minus 1 whole to the power of 3 plus 1. Then
8 minus 6.
minus 6. So this is minus 1 whole to the power of 4 into 2. So is positive.
2.
The answer is 2. So here we are going to write 2. So I did not scroll down because we could not see the matrix, but you can proceed. Right?
Yes, sir.
And the next one. Cofactor of
0.
0. Cofactor of another 0 is minus 1 whole to the power of
3 plus 2.
3 plus 2. 3 plus 2. Minus 1 whole to the power of 3 plus 2 into the remaining value.
4 minus 0. 0.
4 minus 0. So this is minus 1 whole to the power of
Minus 4. Minus 4.
so it is no this is plus 4 only. 4 minus 0 is 4 only. So minus of odd power is minus 1.
Minus 4.
Minus 4.
So this is minus 4. Then go to the next one. What's the next one? Cofactor of
5.
5. Cofactor of 5 is minus 1 whole to the power of 3 plus 3
3 plus 3.
into the remaining value. 2
2
minus 0.
2 minus 0.
2 minus 0. So it is minus 1 whole to the power of 6 into 2. So
2.
2.
So we should write transpose of. What is it? Adjoint A. Transpose of that matrix. Obtained matrix with the cofactors of each element. So let us proceed this one. So what will get this result?
10, 0, 0. 10,
So
0.
adjoint A equal to yes, 10, 0,
10,
0,
0, 0. Minus 10, 5, 0.
2,
2 minus 4, 2.
This is what adjoint A. Now we have to find A inverse.
Trans
A inverse equal to
10, 0,
1
0.
by det A into adjoint A as per the formula. So substitute in that. So we know that this is 1 by 10 into adjoint A is 10 minus 10, 2, 0, 5 minus 4, 0, 0.
0, 0, 2.
So you follow the procedure, right? Then multiply each element with 1 by 10. This is 10 by 10, 1. This is minus 1, 2 by 10, 1 by 5. This is 0. And the next one.
1 by 2. 1 by 2.
Minus 2 by 5. Then it is 0.
0,
It's also
0,
0.
1 by 5.
1 by 5. That's it. Therefore, this is A inverse. Inverse of the given matrix. So if they ask to find A inverse, you can use any one method. But if they ask to find A inverse using the elementary operations, you should use which we learned in the matrix only. Right?
Yes, sir. Yes, sir.
Do you have any doubt regarding this?
No, sir. No, sir.
No, sir.